Good morning, good afternoon, wherever you are in the world. Happy to have you here today for another installment of the TIBCO Analytics Meetup with myself and the TIBCO Data Science team. Standard confidentiality disclaimer. Going to give you a brief update on our analytics offerings, and then we're excited to have a demo today on machine learning for pattern recognition, an example of how to classify semiconductor wafers. And a community update as well. Okay, so a couple of things to check in on before we get into the meat of the presentation. We send out a quarterly newsletter. We sent one of those out right around Christmas time, and the latest one is about to land. Yeah, feel free to sign up for those. There's a subscription link there. Take a screenshot of it, or we'll send these slides around. And also you can contact us anytime at askdatascience@tibco.com. Now, one exciting thing in the newsletter this quarter that's about to launch is our analytics forum. So this is, we had a great one of these about a year ago. This one's the last week of May. Now, this one's digital, like our TIBCO Now experience. The call for papers is open. Registration is open. This is an event that has its heritage and history in Houston as the Houston Energy Forum. We made it more broad analytics offering a couple of years ago, and had some amazing Spotfire submissions, and across the board exciting event with Spotfire, TIBCO Data Science, streaming, our data management products. There's a very popular hackathon we're coming back with this year. There's training on all of our products, and it's really is an exciting experience. A lot of our customers, vendors present as well. So really encourage you to come along. It's going to be awesome. Okay, so getting into today's presentation, just wanted to remind you of the offerings that we have in visual analytics, data science, data management, and the people that use our products who want to find insights in the data, who want to deliver data in a governed way, who want to put analytics and insights into operations, and then we're all serving the business leadership who want to grow the business and outpace the competition. So the business leadership's right on top here. They're looking for interactive dashboards, embedded analytics, predictions, alerts, image analysis, and so on. And then the analytics and data science and DevOps folks, that's folks who I think we've got on the call today, are building out reporting, information portals, dashboards, interactive analytics workbenches in Spotfire, the second one, data science labs, DevOps studios. These are all the customers of the TIBCO products, and the people here are BI developers, business analysts, data scientists, ML engineers, data stewards, and then down on into the data management folks building out data marts, managing data lakes, streaming data, doing master data management, metadata classification, all against the corporate data assets. And now we are just, blessed with an overabundance of awesomeness when it comes to software in these areas, from Jaspersoft on the left, Spotfire, data science, streaming, our new acquisition of WebFocus from Information Builders, and then in the data management area, Information Builders Omni for ETL, TIBCO data virtualization, EBX and TCMD for master data, metadata management. And the analysts have been writing about how all these worlds are colliding, how data management colliding with developers and data science and visual analytics. And right in the middle of this is the collision between data science and analytics, visual analytics. And a lot of folks have been calling me to get my view on this. So I did an interview with Tech Republic about the collision between developers and data analytics. Our work with the COVID app is, I hope you've all seen this. This really is a thing of beauty. Spotfire interface, but running all kinds of Python and R for doing data science and predictions of forecasting of the pandemic in different regions. Figuring out hotspot analysis on maps, reproduction number estimation at a very local level. This really is got a lot of kudos to this application, and newspaper style. Scroll down and pick the analysis you want to dig into. And we've just recently added the vaccination tracking, but really as a showcase for Spotfire and the combination of Spotfire and data science with Python, R, and so on, to find insights, but also make predictions as to the trajectory of the pandemic globally, but at a very local region. Part of that collision of data science and visual analytics and DevOps, we got featured by a blog written up by our folks, partners at AWS, about how we're doing the DevOps part of that, along with the hosting and analytics development. So this whole collision thing is really a thing. We've been doing this for ages, you know, Spotfire plus data science. And so we're calling this hyperconverged analytics. So combining data management with insights from visual analytics to putting that into automatic operations and learning with data science. The combination of our products, especially Spotfire, data science, streaming, data management, allow you to build out solutions in your different vertical areas. And today we're going to hear about one of those in terms of proactive yield management in the high-tech manufacturing area. Adam and Nico are going to walk you through a solution, you know, based on that. But wherever your business problem lies, if it's in customer analytics for doing segmentation or analyzing churn or cross-sell, pricing, promotion, affinity analysis, this combination of data science with visual analytics and getting that onto the event stream and managing the data coming into that, you know, we've got all the elements at TIBCO for doing that. And so if you think about what hyperconverged analytics really is under the hood, wherever your data are coming from, oftentimes they'll come on an event stream. We can connect with those different sources and integrate them. Some of our customers drop that down into a system of record, a database, and so on, bring that in through TIBCO data virtualization. TIBCO Streaming can take messaging data directly, live data, or whether it's live data or data at rest, we can visualize all of that in combination with visual analytics in TIBCO Spotfire. And that includes inbuilt geospatial and data science methodologies, visual analytics. And then our data science and model ops offerings just drop right in the middle of this to allow a data scientist either in a Python notebook or in R or in TIBCO data science, drag and drop, to create a data science pipeline, and then to put that data pipeline right into the flow of the event stream, and calling out to engines like R and Python and Spark. And we've got a new offering coming up. It's in gray here, model ops will be up coming up this year. So we're going to be featuring all of this at the TIBCO Analytics Forum, all these products and how they work together, and also work in combination with Amazon and Azure and GCP with different services that feed into those different components. So TIBCO Data Science is one of the featured products in this area with the inbuilt Python notebook and drag and drop visual interface, both for big data in a cloud environment and for Workbench for on-premise in memory. We've got you covered there. Collaborative environment allows the Spotfire developer to collaborate closely with the data scientist. And that combination of Spotfire's inbuilt R and Python engines, and which can be invoked from a marking. You see that little marking I'm doing on the map chart there that's calling out to a Voronoi polygon analysis that includes clustering as well as drawing the actual polygon. And those data functions are now manageable in the flyout in Spotfire 11. You can bring your own data functions in as well as ones that we have with the product. And that whole experience can be supplemented with TIBCO Data Science, where you can go and, rather than writing Python or R code, you can go and create a visual workflow for doing data blending and machine learning, and then call that workflow from the data function construct inside of Spotfire. And you can pass parameters to the data science Team Studio workflow. You can share the same data source. This works with enormous data, terabytes of data. So this whole combination of Spotfire and data science at TIBCO is pretty exciting. And Adam and Nico are going to show you some of that. So our mission is to be able to give you the tools you need from defining a project to acquiring the data, blending the data, exploring it, developing features, building models, deploying models, monitoring models, refreshing them, that whole life cycle. And this product we've got coming out pretty soon this year, is really interesting in that regard, the TIBCO Model Ops. And we've written an O'Reilly book to describe what's involved in Model Ops and what we're aiming at with that new product later this year. So that's just a brief summary of what's going on in the marketplace, the TIBCO products. And now I'm going to hand off to Nico and Adam to talk about this pattern recognition, pattern classification example. So Nico, I think I'm going to hand to you first, right?
Yes, sir. Yes, sir. Thank you, Michael. I'll just go and share my screen.
Okay.
Perfect. Can you see my screen?
Yep.
Great. Yeah, thank you, Michael. So we'll see a little bit of what you're talking about with hyperconverged analytics, specifically in this case and in this demo. We're going to be going over work that we've done with customers in the manufacturing setting, in the semiconductor wafer manufacturing setting. And as Adam is going to show you later on in the demo, the core idea here of what we're going to talk about is empowering an end user. In this case, a process engineer at a manufacturing plant, and empowering them with the ability to quickly and effectively create machine learning models. And those models can recognize different spatial patterns or anomalies in raw wafer data. And additionally, not only can they recognize these patterns, but they can also tweak the model and tune it. So it's representative of what they're actually seeing on the manufacturing floor. And then they can take that model and deploy it. So instead of sitting at their desk and manually inspecting these wafers one by one, they have a deployed model that automatically identifies these sort of patterns or wafers of interest. So I think it's going to help a little bit to set the tone here. What are we actually looking at? What are we measuring? What are we training a model to find? And so if you think about the manufacturing process of wafers, right? You have these silicon wafers. They're fabricated, they're created, and then they go through a series of tests. And then after the tests, they're sliced up into individual dice. And then those dice are further segmented and used or packaged in different kinds of products or integrated circuits, depending upon how they perform in those tests. So this is where the dashboard and the demo comes in today, is sort of in between the creation of the wafer and then the dicing section. And this is the testing section. And when you test these wafers, you're testing all sorts of different things, right? You're testing voltage, you're testing the speed of sub-processes, electrical current tasks, right? You have hundreds and hundreds and hundreds of these tests. And these tests bring back numerical values. And these test values are what make up spatial patterns of the wafer, as you see here, sort of on the right-hand side of the screen. And this spatial pattern is what we're trying to train a model to recognize. And the reason that we're doing this, and that Adam will walk you through, is because there's a lot of business value here. Right, spatial patterns on wafers are sort of indicative or can be used for two major objectives or two major things. The first is that certain kinds of spatial patterns found on a wafer might indicate how that wafer is best sliced and diced or packaged, right? As I mentioned earlier, downstream in the process. So if you're able to correlate a specific pattern with certain products, you can see that these dice are best suited for a specific kind of product or a specific type of integrated circuit sort of downstream. So if you're able to recognize these patterns, you have some sort of forward planning in terms of your business roadmap. The second scenario is that a pattern might indicate something is actually wrong in the manufacturing process, right? It might be an abnormal spatial pattern that you don't see very often. So you know something is wrong in creating the wafer. And if you know that, then you can catch it or stop it or fix the problem before it sort of propagates outwards, right? And then you have hundreds of wafers with the same systemic issue. If you're able to catch that automatically and fix it, you can save a lot of money in the process of doing that. So I think with that in mind, I'll give it over to Adam to walk us through the demo.
Yep, thank you, Nico. I'll just share. So right here is our demo within Spotfire. So what you're looking at here is all of this wafer data that Nico mentioned. And so the point of this page is to be able to create patterns of wafers that you might be interested in creating models to automatically detect. So on the left side of the screen, we have all of the wafers here. So we have a ton of, I think around 500 wafers. And then on the top left, what we have is actually a result of our complex data pipeline that goes through a series of processes, including for a bezel transformation, singular value decomposition, and then finally generating clusters for which you see here in the top left. So what you're looking at is the average wafer value for a specific cluster. So if you see something that you might think might look abnormal or might look like something you've seen before, all you do here is drag over it. And what it will do in Spotfire, it'll display all of the specific wafers you just selected here on the bottom left. So now you can see that these wafers look like something like a heart. So if you want to create this into a pattern that you want to detect in the future, all you do is go to this middle panel, type in heart, click add to new pattern. And now those heart wafers are in the heart pattern on the right side of the screen. And what we're trying to do on the right side of the screen is we're kind of trying to create this library of patterns that we're interested in. So you can see that I also have a ring pattern here, and this also has a certain amount of wafers in it. So you can imagine building up this library with as many patterns as possible that you're interested in. And then once you've done that, you can move on to the modeling page. You can be able to create models to recognize them. So I'll do that. And if I, on this page, this create models page, all you have to do is go to the top left, select the certain pattern that you want to create a model for. Here, I'll click on the heart pattern. And next step is to just click run model. And what this is doing is it's creating a machine learning model, a random forest that uses these heart wafers as the training data, as the examples for the model to be able to learn to recognize this specific shape. In doing so, then the model will be able to pick up that pattern on all of the rest of the data. So we can see the results of our model here, but I'll explain what this confusion matrix is. So this is a typical way to look at the results of machine learning classification model. So on the row-wise, we have what the model predicted to either be a pattern or not a pattern, whereas column-wise, we have what we had already tagged to be a pattern or not a pattern on the previous page. So if I were to click on these 15 wafers here, these wafers are the same as the ones we already found, and it found all of them. Now, what's really interesting, though, is this bottom left panel. These are your quote-unquote false positives, things that the model predicted to be a pattern that you didn't find in the last page, because it's going to be hard for you to sift through all of the data and find everything. But what you can do here is you can go through the series of steps to correct your model. So all you have to do is find all the things that do look like hearts that the model found. Since you're a little bit smarter than the model at this point, you can kind of augment it and increase like human insights into machine learning. So now that I've done that, all you do is click run model again. And what this does is it starts off this iterative process where we're able to add new examples to our model and make it better for the future, and also pick up more of these examples, because the more examples that you have in your model, the more accurate it's going to be when it's predicting on new data. So you'll see that there are fewer false positives now, and you'll see that the accuracy scores have actually gone much higher. So all you do again is you just add these back. And if I were to run this one more time, one sec, sorry. If I were to add this one more time, then the model will get even better. And then you'll essentially exhaust all of the wafers in your original data set. So I guess I'll wait for this to end here, but you can imagine that you just will do this for all the different target patterns you have here. So I'll do this for the ring pattern and all the other things I found in that library of patterns on the previous page. And then I can click Save Model each time so that these will be ready to deploy when we want to run them on new data. So you'll see that as the result of running that for the third time, there are no more quote false positives that don't look like a heart. So we can safely say that those were all the hearts and we have the model ready to go. So after saving that model, you have two ways to kind of deploy it. One of these ways is to do it in batch scoring. So in this case, someone comes in maybe in the morning and wants to run these models on the past 7 days of data. So what they'll do is they'll just go and click on the specific models that they've already created. So I have heart selected, moon selected, and I have ring selected. And then clicking this run models on new data, what you'll get is this screen. And you'll get, you can see that there are 32 hearts in your new data that it found. There are 15 moons and 32 rings. So what this did was it applied those models and it gave them a classification score for every single one of these wafers, and you can view the results easily on this page. The other use case is to score on streaming data. So if I open up TIBCO Streaming, and I actually just click this one button, what this will do is it will start the initiation of looking at this real-time data. So this is the same use case, but instead of getting in terms of batch, instead you're getting in real time. So you can imagine that actual machines on the factory floor might be reading out that sensor data, and you're watching it come in one by one. So if I were to click on this one donut pattern, we could see that this might evolve and get, so you could see that there's a couple more that have come in. And why this might be valuable is because if you're able to get something right off the floor, that can make you able to take immediate action, which could be very valuable because testing could be a very expensive process, and it could be very valuable to do this. So that is all of my presentation here. If anyone has any questions, I'd love to answer those.
Thank you, Adam. So we did actually get some questions in, both via chat and the Q&A. So let me start with the questions about your demo. So one of them is about how you can, or once you have trained these models, where you can deploy them. I think you showed some of that, but can you maybe just summarize what you've shown us?
Yeah, so the models that were used were actually Python sklearn models. So these can be used actually anywhere, and these are going to be saved easily to your local folder. So you could deploy these in a Python notebook. You could deploy these in some script anywhere else. You're not limited to just doing it in Spotfire within that environment.
Great.
Yeah, very impressive. I wanted to find a little bit more out about how you built it and so on. But I think just before I get into that sort of line of questioning, Nico, can you tell me a little bit about the way you characterize the patterns on the wafer, like the circular pattern? So how did you get the structure? How did you characterize the structure on the circle?
Yeah, for sure. You know, when we're building these models, we aren't just taking the raw wafer data and passing it to a random forest model. The first step is, like you said, to sort of categorize those or featureize the shapes on a wafer. And we do that by actually doing feature reduction. And it's a really interesting method called Fourier-Bessel transformations. So it's a lot like a regular Fourier transform, except you have a matrix of basis functions, which sort of represent all possible radial patterns on a wafer. And as we get these raw wafers in, we're able to decompose it into sort of a vector of coefficients of these basis functions. So every wafer is able to be represented by some linear combination of a coefficient and these basis functions.
Gotcha.
The last thing about it is it's really great because it's totally impervious to null values. So at the end of it, we get this vector of clean coefficient data, which we can then further do, SVD on and really feed that to our model. So it's a really interesting process.
Oh, terrific. So basically, you get out the features as the coefficients of the Bessel functions. That's like a spatial version of a Fourier transform. And then each one of those dimensions can be then, you can reduce the dimensionality of those depending on the sparseness or the structure. And then that reduced set of coefficients then goes into the random forest model.
Yeah, you got it.
Okay, cool. Very cool.
Thanks.
So I got a question for Adam then. So Adam, you're taking that that sort of mathematical way of representing each of the individual wafers and feeding that into the random forest. How are you doing that? Is that through a piece of Python code that we call from Spotfire's Python data function, or how does that work?
Yeah, so that's it's being fed into a Python data function, which is Spotfire's built-in Python engine. And yeah, we're able to just use standard libraries that are in Python and be able to take a little bit of the data in Spotfire, feed it into that data function, and build that model, which will then be able to be stored just in your local file, but also output the result of that model, which is seen in that confusion matrix that I showed.
Oh, awesome. So it's kind of like a scikit-learn type piece of code that fits the model. Okay. No, really awesome the way you've been able to pull together the raw data, the feature engineering, the Python model building, and do all that within the Spotfire visual analytics framework. I wanted to ask you guys one more question about, in my presentation, you saw how we, this combination of visual analytics with data science, streaming, data management, how we're calling that hyperconverged analytics, in part due to this whole explosion with Gartner and the analysts, and people are writing about this collision between all these different worlds of data management, data science, visual analytics. Can you guys give a few thoughts on as we were taking this out to customers and out into the manufacturing floor? You've got citizen data scientists who don't really know much about writing Python code or R code. How do we, there's big data problems to deal with that go beyond Spotfire. That combination of products that I alluded to, how do you see that working out? And can you give us a feel for how, in particular, Spotfire and TIBCO Data Science work together, or Spotfire and DV, or Spotfire and Streaming? You had some of that in your demo, but maybe you can make a few comments about the combinations of those products and how they apply to different situations.
Yeah, for sure. I can take that one, Michael. So we're actually working on a POC right now, basically trying to integrate this demo that Adam showed into TIBCO Team Studio, right? So right now, how we're doing it is using the scikit-learn Python script. But we can actually sort of transfer that logic into Team Studio, which is a visual-based machine learning platform that also works on big data too. So what we can do is, using the big data function, you can connect Spotfire, sort of a visual interface, to Team Studio as the real kind of hardy back-end engine to work on big data.
Excellent. Yeah. So Team Studio, Nico is referring to as the TIBCO Data Science Team Studio. This is our data science offering for big data. It runs through distributed compute, Spark clusters, and there's really, there's no limit to the data set size. And in some of these applications, there really is a lot of data. These wafers are coming off at a pretty rapid clip. There's literally thousands of columns, millions of columns of data associated with them, because not only do you have the yield that I think Adam was focusing on, but you've got various tests, pass fail, electrical tests. You've got all of the process parameters, the machine settings. I mean, it goes on and on, the number of dimensions of this problem. And so it feels to me like, as a practical matter, to put this out into production, you're going to need that combination of the big data science offering combined with the Spotify visual analytics and also combined with streaming to take the new wafers as they come off the manufacturing process. Is that what you're thinking with this new work stream you've got, Nico and Adam?
Yeah, absolutely.
Mm-hmm.
Okay.
And that's a nice,
so
nice segue, to the community section. And we also had a couple of questions about trial and one specific question about the reliability of this pattern recognition. So maybe Nico and Adam, you can take a look at that question and try to answer. Otherwise, I would just recommend send us an email to askdatascience@tibco.com and we'll get back with you if they're very specific questions. But to confirm, we can support trials. So again, email at us and we'll set up a trial for you.
And Nico and Adam can be answering those questions to everybody, Helene, while you give us the community update.
That's right. Yeah. So I'll go through this relatively quickly. But the community is really our place where we share these applications with you, so you can learn and you can see how we've done this. They've been developed for that purpose. So you'll find guidance, demos, starter apps to get going. The AI on demand page on our TIBCO community is really a great place to find this type of information. We're also publishing some tech tools. Michael mentioned about our broader ecosystem and how we can use the TIBCO platform in combination with, for example, machine learning tools that are published by cloud providers. So that's really handy. And we're trying to make this as easy to use for you as possible. We're promoting and explaining a lot of the methodologies in our TIBCO Spotfire YouTube channel that's been around for quite a while and keeps getting updated. There's great videos. Also, we're posting the Dr. Spotfire sessions there, which are monthly sessions where you can learn more about Spotfire, sort of fueled in terms of agenda by the questions that we get in our various channels. And we've recently launched a data science YouTube channel. So that's really great, I think, for all of the users who, it's good to split the content a little bit by the personas that are using the software, but also collaborating in teams to achieve building these AI applications. So you'll see the recordings of this TIBCO Analytics meetup there, the Dr. Data Science sessions, and our sort of tips and tricks videos and enablement videos for data science. So the Dr. Data Science sessions is a series that we started last year, also a bit of a companion to the Dr. Spotfire sessions, but focused on the data science user. This time we're looking at a series that covers the whole end-to-end process, looking from a data science sort of workflow perspective. So as Michael mentioned as well, from going from data exploration, data prep, feature engineering, modeling, testing, model ops, and then looking at all the problems that you can encounter along the way, wrong sets of data, not enough model accuracy, any other problems that you can think of, like your requirements changing, for example. So this should be a really fun session to join. And my final thing to point you to is the enablement hub. So we've continued to develop and sort of organize this enablement content on the wiki pages from the TIBCO community, helping you to find a logical learning pathway, both for beginners as well as for more advanced users who want to expand their skills for Spotfire as well as our Team Studio products. So with that, I wanted to thank everyone for joining. Thank you for all the questions. We'll definitely get back to those in more detail. That email address, askdatascience@tibco.com, is going to be useful if you don't know who to contact. And also that newsletter, please sign up for that, because that will be our way to remind you of the next quarterly meetup coming up. You'll have to subscribe. We have to comply with GDPR, so please do that for us so we can inform you. And hopefully through the YouTube channels and the TIBCO community, you'll always be able to find us. So thank you, Michael and Adam and Nico, for presenting, and thanks everyone for attending. And we look forward to seeing you in the next event.
Absolutely. Thanks, Adam and Nico, for a great job, and Helene on the presentations today. And hope to see everybody at the TIBCO Analytics Forum. Please register, and if you want to speak, fill in the call for papers for speakers. Okay, over and out.